Hey guys, let's get started on the sample questions for the student-produced responses of the SAT math section, so page 318 of the SAT prep book. So problem 1 is a table below classifies these elements according to metal, metalloids, nonmetals, and their state of matter, so solid, liquid, gas. And the answer is, what fraction of all solids and liquids are metalloids? So our fraction here is what fraction of solids and liquids are metalloids. Okay, so that's the fraction that we have to set up. And in the table, we can see that metalloids, there's 7 solids and 0 for the liquids, out of the total solids, 90 and 2 liquids, which gives us 7 over 92, and you can grid that in because you have 4 grids here, 7 divided by 92. Okay, so there's your answer number 1. You can also put that into a calculator and spit it out as a decimal as well. Okay. Let's move on to number 2. A typical image taken of the surface of Mars by a camera is 11.2 gigabytes. A tracking station can receive data at a data rate of 3 megabits per second for a maximum of 11 hours per day. If 1 gigabit is 1,024 megabits, what's the maximum number of typical images that the tracking station can receive from the camera each day? So we want our final answer to be some number of images per day. Okay, so we'll have to do a lot of units manipulation until we get to this point. So let's start with 11 hours. Okay, we know that you can transmit 11 hours in one day. Okay, and no, I'm not saying that there's 11 hours in a day. All I'm saying is that you can only work basically for 11 hours per day. So don't get that confused with what you typically think of as 24 hours in a day. This is different. Okay. Now we want to convert that to seconds because we know that it's 3 megabits per second, which is the data translation rate. And then once we get into megabits per day, then we can do gigabits per day and then change that into images per day. So you can see we'll march along until we get to the images per day. Okay, we already have the day in the denominator, so we're good there. So we just got to get images up in the numerator. So 11 hours, so we said get into seconds, so 60 minutes in an hour, 60 seconds in a minute. Okay, so here we go. That cancels. We can get seconds per day now. That should work. And we know that you can do 3 megabits per second. Okay, voila. Now we have megabits per day. Well, now we need to get it into gigabits per day. And we know that that conversion rate is 1 gigabit. So 1 gigabit per 1,024 megabits. Okay, so there. And now we know that we have 11.2 gigabits per image. Okay, so then we can do, let's see, one image is 11.2 gigabits. And note we put the gigabit on the denominator so that it would cancel with that gigabit and leave us with the image in the numerator. Okay, this is multiplying. I just wrapped it around because I didn't have space. So now we can use our calculator, and if you punch all of this into your calculator, and I can go ahead and do that. On the real test, I'm sure you'll have a real calculator. I'm just using my phone. So it's 11 times 60 times 60 times 3 divided by 1,024 divided by 11.2 gives us 10.36. Okay, and that's what we have, images per day. Okay, but notice here that we got a decimal. On the real test, you want to say 10. Okay, you don't want the decimal. You want to round down because in one day you can only transmit for 11 hours, and transmitting a part of an image doesn't count. So you just want to round it down to 10. So make sure you read the question carefully, and you want to grid in here just 10. Okay, and there's your answer. And again, notice that we saved the calculation for last. So you want to set up the entire problem and then use your calculator, because once you use your calculator, it's pretty quick. So you want to save that for the end, and you don't want to be stuck doing calculations in the middle until you're very confident of what it is that you're calculating. Okay. Number 3, it's an inequality problem. So we have this inequality and we want to say what is a possible value of 9t minus 3. Well, we'll notice here that 9t minus 3 is simply this multiplied by negative 3, right? So we can just do that. We'll multiply the entire inequality by negative 3 and see what happens. So negative 3 times negative 9 over 5. Now we have to be careful here. When you multiply by a negative within an inequality, you have to flip the inequality, right? So now we get our 19 minus 3 that we wanted. And again, flip the inequality. Negative 7 over 4. Okay. So then we can multiply this out. 7 over 5. 21 over 4. Okay. So now we have this, and we just have to pick some number to grid in that's between these two decimals, these two fractions, excuse me. So what we can do then is punch those numbers into our phone or your calculator. This is 5.4. This is 5.25. So just pick a number between 5.25 and 5.4 gridded in. So I'd say 5, excuse me. Yeah, actually I'll look 5.3, right? That'll work. So you can also do 5.31, 32, etc. Okay, number 4 is a geometry problem. So we have a triangle that looks like this. Okay, and we know that this is 32 feet, this is 24 feet. And we know that those two angles are the same, which tells us this is an isosceles triangle, right? And we're asking for the cosine of x. Okay, so we have to remember that the cosine of x is defined as the adjacent leg of a right triangle divided by the hypotenuse. So adjacent over hypotenuse. So this is our x. We have a hypotenuse, but we don't really have an adjacent side unless we make our own right triangle by dividing the triangle in half here. Voila, there's a right triangle, right? And we want to know this side. That's the adjacent side. Well, we know this whole length is 32, which means this adjacent side must be half of 32, which is 16 feet. We know hypotenuse is 24 feet. Okay, and therefore we know that the answer is 16 over 24, or you always want to simplify when you're on the SAT. So divide by 8 on both sides, you get 2 over 3. So you can put that in as 2 over 3. There's your answer.